Now, finally, today, in talking about clay and how, kind of how clay works, the history of clay, why clay is used, it's really important for us to understand the stages clay goes through. And when I say stages of clay, I guess I really mean the stages of clay and ceramic, because as you know, the stuff changes from clay to ceramic. So we should already have some familiarity with the process of going from wet, from wet clay, like I show here, just a lump of clay out of the pot, or here, to leather hard when it starts to get real stiff, to bone dry when it's totally changed color, and then we can slake it and put it back to leather hard, back to wet. We can slake it and make it slip or slurry, and then let that dry out and it's back. Right, this cycle of going through these 4 stages of clay can just repeat endlessly, essentially. That's all clay. Slip is clay, wet clay is clay, bone dry clay is clay. All of those are clay, regardless of clay, clay body or which kind of clay you're using. Once you fire, it becomes ceramic. So to help you understand what's happening as we move through these stages, I want to do sort of a little animation, okay? So we're going to go and pretend we're in a Disney movie, and we're going to zoom in on this pot, and we're going to think about the clay structure. So this is a simplification. It's not scientific, perfection here. I'll show you a more accurate picture in a moment, but the structure of clay is these platelets, and when we have wet clay, what we have is platelets essentially surrounded by water. My water lost its color. It used to be blue. For some reason it changed. Anyway, the little lines are meant to be the water, and so the water is distributed. Ideally, it's distributed evenly between each of these little platelets of clay. Now, if we've got clay that's been sitting for a long time, we might have some organic material. We might have some mold growing, something like that. Oops, I'm sorry, I missed something. So when we talk about wet clay, and what makes it work the way it does is because this water is wrapped around each of these flat platelets of clay. Now, you can do a little experiment that's kind of fun as an analogy, as a comparison. So take a glass cup, right, something with a smooth bottom, and I want you to put it on a wet countertop or smooth table. So get that table wet, put that glass on, and you've probably had this happen before. The cup wants to slide back and forth really well, like it'll slide side to side on that water. Really easy to move it around. It is difficult to pick it up. It has some kind of suction on the bottom of that cup, and it doesn't want to come up. In fact, to pick it up off that smooth countertop, you may find that you have to slide that cup, that glass, off of the counter to pick it up. That is similar, an analogy, right? It's a little bit like what's happening with the wet clay. Those platelets have water between them, and so they slide across each other side to side really easily, but they don't want to pull up quite as well. In fact, if you know from pinching clay, right, that you can squeeze the clay and it squeezes nicely into shape, but when you pull on it, it has kind of a ripped texture. So that's my analogy there. That's how clay does its plasticity thing, because of that water wrapped around. Now, lots of potters like to work with clay that's been aged, and when we say aged, we mean it sat around in a box for a year or two. Or sometimes people put things into the clay to cause them to age. They can put in beer or vinegar. So that beer or that vinegar causes the clay to age a little bit, and essentially you can get a little bit of mold. A lot of times potters talk about the favorite porcelain being blue. That's because of the mold that's in it. So that organic material can essentially help stick those platelets of clay together. Makes it a little bit more plastic, a little bit more forgiving. So this is our wet clay, or our wet aged clay. Water in between each platelet. As the clay dries, what happens is that water leaves the clay, and the clay shrinks a little bit. Each of those platelets come closer together. And so you can see in my little animation here, right, they go from farther apart with more water to closer together with less water. The clay shrinks as the water is removed, and we also are left with the clay shrinks as the water is removed. That's leather hard. Now at leather hard stage, our clay doesn't want to bend as much. It's not as easy to shift it because there isn't clay in between each platelet. And so if we bend, you know, these guys here, they're going to want to crack rather than nicely bend together. If we keep drying it, we get to the point where it's bone dry. And basically, I left a couple water squiggles in because there's actually some chemical water that's actually part of each clay particle when I was trying to suggest it there. But what we're left here with bone dry clay is each of these platelets has come closer together. So we shrank from wet to leather hard, and then we shrank again from leather hard to bone dry. But now our clay is porous. Remember, the reason that slaking works is because you put that bone dry clay in the water rushes into those gaps in the clay and knocks those particles apart. That's what's happening. The clay rushes in, knocks the particles apart, and if you were to not slake, but just put some water on a piece of bone dry, you see that it absorbs really quickly. It goes into all these open holes. The clay is porous at this point. Now, we could just recycle it. We could slake it and send it back to wet, and then we have wet clay, we could age it, then we could get to leather hard, we could get to bone dry again, and we could repeat as many times as we wanted. Or we could stick this thing in a bisque kiln. So if we want to stick it in our bisque kiln, these are some electric kilns, if we want to stick this clay in our bisque kiln, once we fire it, now bisque temperature is a lower fire. In our studio, it's cone 06, which is about 1800 degrees. I'll talk about cones in a moment. But when we stick it into that bisque kiln, it's going to go through a chemical change. So this is not the physical change that we kept having from wet to leather hard to bone dry to slake to wet to leather, on and on. This is a chemical change, and now each of these pieces of clay has essentially fused together. Remember, this is the cartoony animation of it. This is to conceptualize it for ourselves. Our bisque clay, as you can see, is still porous. It has shrunk. We got smaller from wet to leather hard. We got smaller again from leather hard to bone dry. The clay shrunk again from bone dry to bisque, and it's still porous. So if you put some water in a bisque piece or on a bisque piece, it'll get wet, but it won't slake because these particles have fused together. Now let's fire it again. Here's one of our old kiln. These are our electric kilns in the current studio. Here's our old studio gas kiln and some pieces that have glaze in them. We're going to fire them up, we're going to cook them up, and we're going to get them to their maturation point. Now I didn't say glaze fire because the change in the ceramic is what we're worried about, not the color change. We're interested right now in the clay going from bisque, which is porous, little pieces of clay, ceramic stuck together, no longer clay, but now ceramic stuck together, little holes in them, can absorb water, like when we put glaze on. They shrink again to get to their maturation point, and the maturation point is the point at which the clay is vitrified. It's no longer porous, it is vitrified. I better add those words for you. Vitrified or vitrification. This means that the clay can no longer absorb, the ceramic can no longer absorb water. So we call the ceramic mature when it can't absorb water anymore. This is also the point at which our glaze is usually ready or mature. It looks nice. It looks the way we want it to look. But even if we don't ever put any glaze on these guys, at a certain point for our studio, when we're on campus, this is cone 10 or about 2350 degrees Fahrenheit. When we're firing in the online class, we're talking about 2200 or so, cone 6. So a little bit cooler than cone 10. Anyway, the clay is designed to be vitrified, no longer porous, at this temperature, the maturation point. All right, so just to head back and review, to make sure we're all on the same page, we've got our clay cycle that can just keep repeating through this over and over again, and we shrink through each of these. Slip to wet is technically shrinking, although we usually don't measure the size of the slip. Wet to leather hard, it shrinks. Leather hard to bone dry, it shrinks. It shrinks again when we fire it, and at this point, either bisque, which is porous, or mature or vitrified clay is ceramic. I keep saying clay, but technically the first four are clay, the next two are ceramic. So if you want to see the real actual thing that's going on here, this is a image from Ceramics Monthly magazine, and you can see the loose powder. They've sort of shown us these platelets of powder from a different perspective than I've shown you, and you can see how they it's porous at bisque temperature, and then those pores they sinter or they grow together essentially during the firing. One more thing to show you real quick, and that is cones. I'll show you these again in a later lesson, but when we measure the temperature of kilns, we usually measure it in cones. Cones are literally these cone-shaped pieces of material that melt at a certain time and temperature. So that's what we mean when we're talking about cones versus temperature.